So now we get into the new lesson for today, or the new material for today, which is solving simultaneous systems algebraically. I should have had a capital S there in the systems. And we start with the elimination method. So solve the following system of equations for x and y. And what I want you to notice here, that's very important, is that the x's are lined up over the x's, the y's are lined up over the y's, and it is a very good thing that the signs are opposite. Okay, the equals are over the equals and the numbers are over the numbers. And I want you to notice also that there's the same number of y's. There's a positive 1y and a negative 1y. So what's really cool is if I add these two equations up, 3x plus 1x, I get 4x, and the y's are eliminated. They cancel, and then 7 and 1 is 8. And then I divide by 4, and I get x is 2. Now, here's a big difference between this and all the work we've done so far. So far, every problem, when we get to the point where it says the variable equals, or like x equals 2, we're done. We don't have anything else to do. And that's simply not the case when we do a system of equations. There's another letter in here, or another variable, namely y, and we have to go back and solve for y. So I can use either equation to go back and solve. Usually I would use the top one because everything's positive, but I do want to show you that the bottom one would work just as well. So I substitute in a 2 for x. All right, minus y is 1. Subtract 2 from both sides. Negative y is negative 1. And then if I divide both sides by negative y, or negative 1, I'm sorry, and if negative y is negative 1, then positive y has to be positive 1. And then we can always check. The way you check is you rewrite both equations. 3x plus y equals 7, and x minus y is 1. And then you substitute in both variables. You substitute the 2 for x and the 1 for y. And if you do, you'll see that in the top one, you get 7 equals 7, and in the bottom 1 equals 1 to confirm your answer. Okay? So now, in summary, you want to pair up one of the variables to eliminate, and it doesn't matter if it's x's or y's, but to know which one it is, you want to have the same number of both, and it's better, though not essential, to have the same number of the to have one positive and one be negative. Okay, if you hear that ringing, that's my dog licking the last of her dinner ball. So the first thing you do is pair up the variables to eliminate, and you know to use elimination because the x's are over the x's, the y's over the y's, equals over equals, numbers over number. And then you substitute to find the eliminated variable, and that is to say, I get to a point where x is 2, and then I substitute that back in, and I plug in or substitute the 2 for x, and that gives me the y. And then if it asks, check. Let's have you try this one. Go ahead. And of course, we're doing stop and stop. So I'm gonna stop the video for 5 seconds. You're gonna work this whole thing through. Okay. So I noticed right away my A's are over my A's, B's over B's. The B's match up quantity-wise. They're both 4. One's plus, one's minus. It's absolutely perfect. Makes it so easy. Equals over equals, numbers over numbers. I add them up and I get 4A is negative 4. Dividing by 4 and I get A is negative 1. Then I rewrite either equation, and in this case, I would normally choose an equation, either top or bottom, in which there were as many positives as possible. So I would choose the top one, only because students are less likely to make careless mistakes with positives. So I substitute in a negative 1, and I get 3 times negative 1 plus 4b is 9. That's really a negative 3, so I just add 3 to both sides. 4b is 12, and dividing by 4b is 3. If I want to check, I rewrite both equations. There they are. 3a plus 4b is 9, and a minus 4b is negative 13. And I substitute, or plug in, the values of a and b in both, and I see that it does indeed check. Once again, the summary: pair up the variable to eliminate, solve for the other once you're done. Okay. So I paired up the b's to eliminate. I solved for the other in a, and then I substitute the a back in to go back and find b. If it asks, I check. Try this one. I think by now you've probably seen the problem. If you add them up, you get 7x plus y equals 11. And that doesn't do you any good because there's still 2 variables there. So how can you do anything? Well, first I notice the x's are over the x's and the y's are over the y's. the equals over the equals, numbers over numbers. So I do want to use the elimination technique. The difference between this one and the two previous slides is that neither the x's have the same number, namely 4 or 3, and then the y's have the same number. Okay? Just had an ant run across my fly time. So I'm going to get rid of my ant here. Okay. So the y's don't match up either number-wise. One's 3 and one's -2. So that's not cool. Well, this kind of reminds me of something from elementary school. Like least common denominators. Like I gotta find a way to get rid of or match up. Like in elementary school, I would have had to get a common denominator out of the 3 and 2, which would be 6. And if you already think that way and say, oh, well, I'll just multiply the top by 2 and the bottom by 3, well, then you're way ahead in the game. But what if you don't think that way? Well, there's a little trick you can always remember. If they don't match up and you're not seeing the whole denominator thing, you could just take whatever number, and this is assuming I'm matching up the y's, but it could be with the x's. Take whatever number's in front of the y's on the bottom, and you're going to put it outside on the top to distribute. And likewise, for the bottom, you're going to take whatever number's in the top and put it outside to distribute. Now, if I had chosen the x's, it would be 4 on the bottom and 3 on the top, but I chose the y's. So 2 goes to the top, 3 goes to the bottom, and I keep the same signs because they're going to pair up when I'm done. And check it out. When I distribute that 2 to everything in the top equation, 8x plus 6y is -2. When I distribute the 3 to everything in the bottom of the equation, 9x minus 6y is 36. Now these y's are going to cancel each other out. 8x's and 9x's make 17x's. -2 and 36 is 34. Dividing by 17, x is equal to 2. Now I go back and I substitute that in. I'm going to take the 2 and substitute it in for the x value. I'm using the top equation here. 4 times 2 is 8, plus 3y is -1. Subtracting 8 from both sides. 3y is -9, dividing by 3, and I get y is -3. So what's the difference here? The difference is that they didn't pair up in the beginning. So they were lined up, they were all aligned, and that made me think elimination, but they didn't pair up. And when they don't pair up with a specific number, you can get rid of either the x's or the y's. If you're going to get rid of the x's, you would want 12 x's. Like least common denominators, 4 and 3 both go into 12. Or if you're going to get rid of the y's, you would want 6 y's because 3 and 2 both go into y's. Now into 6. If that's not comfortable for you, and listen, there's a lot of students who don't like fractions, so least common denominators is not something they're very comfortable with. You can just remember, take the bottom number, distribute it to the top equation, take the top number, coefficient. I say number. Take the bottom coefficient in front of the y, because that's what we're eliminating. Distribute it to the top equation, and the coefficient in front of the y in the top equation, distribute it to the bottom equation. And you will always get the y's or x's, whichever you choose to eliminate, to pair up. Here's your check. Substituting 2 for x and -3 for y, I get -1 equals -1. Likewise, 12 equals 12. So summarizing one more time, match the quantity of a variable like finding the least common denominator. If you cannot do that, just switch bottom to top, top to bottom. Pair up a variable to eliminate. Doesn't matter which one. It's easier if you choose and see ones with opposite signs. Solve for the other variable, so I paired up the y's, I solved for x's. And then substitute to find the eliminated variable. I got x, I substituted that in to get y. And then if it asks, check. Now, these problems are not only done, given to you that way, often they're done in word problem form. So let's have you try this without me giving you any instruction. I'm sure you saw questions like this when you were in high school. So give it a shot. Okay. So 3 donuts and a coffee are $5.25. 5 donuts and 3 coffees are $10.75. You'll notice that the D's line up over the D's, the C's over the C's, so everything's aligned, the equals and the numbers. But what I don't have here is the same number of C's or the same number of D's. It'll be easier to just get rid of the C's because I only then have to multiply the bottom equation, or the top equation, sorry, to match up. So I'm going to multiply the top equation by -3. And that negative is a new little step here. But here's the thing. When I multiply by -3, this positive c is going to become a -3c. And that gives me the opposite signs that are so cool to work with. So distributing, -9d minus 3c is -15.75. 5d and 3c is 1075. -4d is -5, dividing by 4. And I should have divided by -4 here, sorry. D is $1.25. Let's go back and get the value of C. I can use either equation, but the top one's going to be really easy. So substituting in a 125 for D, 3 times 1 1/4 is 375. Subtracting from both sides, the price of a cup of coffee is $1.50. Okay? Now, if necessary, go back and watch that a second time until you feel real comfortable with it. The big new step is writing the two equations. Once you write the two equations, everything is as it has been. And once you're confident that you're really good at this and that you can do this at will, let's try another. Okay, so 3 pretzels, 2 sodas is $6.50. Now, I'm using a D for soda. I don't like using an S because sometimes you can get confused and think 2S is 25. So I don't want to have that problem. 3P plus 2D is $6.50. If you want to use an S, I suggest writing a script S because that doesn't look like a regular 5. And then 4 pretzels and 5 sodas is $11. I got to pair up either of these to eliminate. I'm going to eliminate the D's. So that means I'm going to multiply the top equation by 5 and the bottom equation by 2. There's the top equation by 5. How did I know 5? Because it's what's in front of the bottom D. How did I know -2 actually for the bottom one? Because the 2 was in front of the D. It's the coefficient of the D in the first equation. And I also want one of the signs to be negative. I really don't care which one. So the top equation when distributed is 15P plus 10D is 3250. And the bottom one, -8P minus 10D is -22. Adding them up, 7P is 1050, divided by 7. The cost of a pretzel is $1.50. Now let's go back and get soda. 3 pretzels and 2 sodas is $6.50. 3 pretzels at $1.50 each is $4.50. Subtracting $4.50 from both sides, 2 drinks is $2. Dividing by 2, a drink is $1. Okay, so remember, the P's were lined up over the P's, the pluses over the pluses, or plus minus or minuses, whatever, that doesn't matter. But the bottom line is you have your P's over your P's, D's over D's, equals over equals, numbers over numbers, and that indicates that we should use this elimination technique. However, that's not the only way that they can present this problem to you. If you look here, yes, the X's are over the X's, but now the equals are not aligned. That messes things up big time. We can no longer use the elimination technique. When the equal signs do not align, that suggests another technique called substitution. Now, you've actually been doing this for a really, really long time, believe it or not. You go to a soda machine and you want to put a dollar bill in. Back in the day, you could actually get a soda or water for $1. You put a dollar bill in and it kicks it right back out at you. So you try it a couple of more times and it kicks it right back at you a couple of more times. And then you notice the little thing that says exact change required. So you stop giving the dollar and you look at your buddy and he gives you 4 quarters. So then you put 4 quarters in the machine and voila, out pops the soda. So we're going to substitute the same thing here. For the X, I'm going to substitute what it is equal to, namely a Y minus 2. How do I know to substitute for the X? Because it says X equals. As soon as it says X equals, I know that's my substitution. So in the top equation, I keep the 3, I keep the plus 2y, I keep the equals, I keep the 29. However, that y minus 2 is going to now be substituted for the x that y minus 2 is equal to. So I slide it on down there. Now I have an equation that looks just like the equations we've been doing for 6 lessons now. Distributing the 3y minus 6 plus 2y, that's a same side, same operation situation. 5y's minus 6 is 29, add 6 to both sides, 5y is 35, dividing by 5, y is 7. And then just like before, you're going to go back and get the other variable, in this case x. And the really cool thing about substitution is it's usually incredibly simple to find the other variable. Substituting in a 7 for y, 7 minus 2 is 5. That is x's value. So the key to note here is the equal signs are not aligned. Sometimes the x's and y's are also not aligned. That tells you go with substitution. Now in this problem, you're not going to substitute for x because it doesn't say x equals. You're going to substitute for y because it says y equals. So if necessary, look back at your notes, or if necessary, scroll backwards, look at the previous question, and then apply those principles to this question, and let's see how you do. Okay. The first equation, I keep the 5x, I keep the minus 2, I keep the equals 14. However, this x minus 4 here, the y gets traded in for what it equals, which is an x minus 4. So instead of the y here, I put in or substitute the x minus 4. This now looks like equations with which we are very comfortable. Distributing the negative 2, I get 5x minus 2x plus 8, right? Because negative 2 times negative 4 is positive 8, equals 14. I'm going to subtract, combine like terms here. 5x minus 2x is 3x plus 8, subtracting 8. 3x is 6, dividing, and x is equal to 2. Okay, great. X is equal to 2. What does y equal? Well, y, it says, is x minus 4. So again, I'm substituting. This time I'm substituting the 2 in for x. Y equals 2 minus 4. Y is negative 2. Okay? All right, so again, they're not aligned. Suggest substitution method. Pick out whichever variable it says. If it says y equals, you're going to substitute for y. If it says x equals, you're going to substitute for x. If it said m equals, you would substitute for m. Try this one. Go ahead. So my first question is, what are you going to substitute for? You're going to substitute for b because it says b equals a minus 2. So I rewrite the first equation. I keep the 3a, I keep the minus 5, I keep the equal 0. But I'm going to put an a minus 2 in for b. Now I just solve it the way I know how to solve it. Distributing the negative 5, combining like terms, subtracting 10, dividing by negative 2, don't know why that said x, a is 5. Well, that's great and wonderful, except now I have to substitute a 5 in for a. So b is going to be 5 minus 2, b is 3. Okay? All right, so that's the substitution method. Now let's go to a word problem. And I consider this word problem fairly tricky, mostly because of what it doesn't say, not what it does say. So translate into algebraic equations and then solve. I would recommend that if you are having a hard time, underline everything you think is important in this problem and make sure you use everything you underlined. Okay, before we begin showing you the answer, I just want it duly noted that one of the top 10 best Broadway shows ever made is Springsteen on Broadway. I might even say it's number 1. It was really amazing. I took my son to see it. Truly spectacular. I don't know why it's not on the cover of this entire little thing I cut out from Broadway shows. But anyway, $12 for every adult ticket, $5 for every child ticket. A little later on in the problem, it tells you that the total receipts that they took in was $1,280. Now, the suitor, this is the hard part. I think, having taught this question for a long time, virtually every student will get this. Now we get to the hard part. And that's why I recommended that you underline everything. At some point, you should have underlined that there's 130 tickets sold. You have to use that. If you don't use it, you can't go any further in the problem. Well, what does that mean? Well, there's two types of tickets. There's adult tickets and there's children's tickets. Altogether, 130 tickets are sold. In the previous problem, every adult ticket cost $12 and every child ticket cost $5. So multiply the adults by 12 and the children by 5, and you got to come up with the total receipts, $12.80. Now I got to come up with the total number of tickets sold. But there's only adults and children. It's not like one gets weighted differently than another. So adults plus children is 130. Now I have the A's aligned, I have the C's aligned, I have the equals aligned, and the numbers aligned. I do not suggest you go with substitution. Go with elimination. Let's multiply the bottom equation by -5, and that'll pair the C's up. Now, 12A minus 5A is 7A. The C's are eliminated, hence the name elimination method. The equals line up, and if I subtract, I get 630. Dividing both sides by 7, the number of adult tickets sold was 90. But remember, adults and children added up to 130, so the child tickets had to be 40. Let's summarize when to use elimination and when to use substitution. Take a look at these two and determine which you would use substitution on and which you would use elimination on. Don't actually do them, just determine which is which. Okay, so in the first case, I would use elimination. Why? Because the X's align, the Y's align, the equals align, which is really the first key thing to note, and the numbers align. So that indicates to me elimination. In the next one, they do not align. The equals are out of whack. That means to me that I should go with substitution. Okay? Happy recap on the recent material that we've done. By the way, you might ask, how come I say happy recap? I'm a New York Mets fan. Don't hit me. And for years, the Mets broadcaster was a man by the name of Bob Murphy. And every time the Mets won, no jokes about how rare that was, Bob Murphy used to say, and now for the happy recap. So, the first thing you want to be able to do if you're graphing is get the linear equation into y equals mx plus b form. Identify the slope and y-intercept. Begin at the y-intercept. Move according to the slope. That's why we use m for slope and b for y-intercept. If simultaneous equations, in other words, graphing two at the same time, graph each line individually and find that point of intersection. That is your solution. Now, for algebraic solutions, if everything aligns, you're going to use the elimination technique. Don't forget the little trick with the variable there, top to bottom, bottom to top. And if not, then the substitution technique. Okay? All right. That is our second and final video for today.